we go. This is lesson 7, rationalizing denominators with square roots. So, in math, we have fractions all the time. Any number that is rational means that it could be written as a fraction. Okay, so when we say rationalize something, we're saying guarantee that it's a fraction. So we, in math, you know, like the number 2. Well, let's start with something simple, like, oh, excuse me. Let's start with something simple like 1/2. Is 1/2 a fraction, class? Yeah, of course. So is it rational? Can it be written like a ratio? Yes or no? Yeah. Okay, what about the number 2? Is 2 a fraction? Yes or no? It is a fraction because it's automatically over 1. Any whole number is a fraction. Why? Because any whole number is a fraction because it's over 1. Does that make sense? So it's rational. You got it? Okay. So like last week when we had, let's say we had an example like this, 1 over x to the 1/2. Okay. We didn't like this in math because this is not a rational fraction. This is, we needed to get that the fractional exponent out of the denominator, so we had to multiply by the next whole number, which in this case would be x to the 1/2, right? Remember doing that last week? The word that's called is called rationalizing the denominator, meaning we want to make it a fraction. We want to make it a true ratio. So we're going to work on the same concept today, except we're going to work on it with square roots. So just like this example here, 1 over x to the 1/2. This is just like saying this. Right? Wouldn't you agree x to the 1/2 is saying square root of x? Do you all see the correlation to these two things? So we do not like this square root. So I'm going to teach you how to get rid of that square root sign. Okay? Here are the steps today. If the denominator is a square root, multiply the denominator and numerator by itself. If the denominator is a binomial with the square root, multiply the denominator and the numerator by the conjugate. And then we simplify. Okay, I'm going to talk to you about what a conjugate is. Yesterday we talked about the shortcut. Remember we had an example like this, 7r plus 8 times 7r minus 8. What's the shortcut when you see 7r plus 8 or 7r minus 8? Someone raise your hand. Yes?
You just multiply the 7r times the 7r and the positive 8, plus 8 and then minus 8. Good,
so 8 times 8 is 64, put a minus sign. Okay? Remember the shortcut yesterday? Okay, so this is the hint for the conjugate. Okay, I'll talk about that. Okay, number 1 and 2. Just watch right now. So number 1, I don't like seeing a radical in my denominator. Right? That's something in math we don't like seeing. We need to clean it up because it's not appropriate to leave the answer like that. So we need to rationalize the denominator. So the first thing I want to do is take a look at what my denominator is. It is square root of 6. We don't like that. So the way you get rid of it, if it's just a monomial and it's just the radical, you multiply by the radical on both the denominator, so rad 6, and the numerator. Okay? Because rad 6 times rad 6, if I do a side problem, rad 6 times rad 6 is like saying rad 6 squared, right? Isn't rad 6 just like saying 6 to the 1/2 power? Would you agree? What's 1/2 squared? 1, right? So 6 to the 1 power is really just 1. Do you all see that? You don't have to do this work all the time. But when we multiply rad 6 times rad 6, the answer is 6, right? So all of a sudden our denominator is rad 6. Now in the numerator we have 3 rad 4 times rad 6. So all you have to do is multiply coefficient times coefficient. We have 3 times, there's a 1 in front of this rad 6 here, so 3 times 1 is 3. And then rad 4 times rad 6 is rad 24. I'm going to simplify. I know that rad 24 is just like saying, 4 times 6. And I know 4 is just like saying 2 times 2. And 6 is like saying 2 times 3. So really we have 2 2's here. So 3 rad 24. 24 is like saying 4 times 6. Square root of 4 is 2. So we got 3 times 2 times rad 6 all over 6. So we got 6 rad 6 over 6. Simplify. What goes into both 6 and 6? 6 does, leaving just 1 and 1. So the answer is rad 6. Okay. Seems like a lot of work. Yes, it is a lot of work. You have to rationalize it, but this is the appropriate answer. If you ever leave your answer like the original problem here, it would be wrong. Okay, so you have to rationalize the denominator. Again, what did I do? I'll show you again one more time. First thing I did is I looked at my denominator. It's a rad 6, so I don't like having a radical in my denominator, so I multiplied by rad 6. I know that rad 6 times rad 6 is just like saying rad 6 squared, which is like saying 6 to the 1/2 times 6 to the 1/2, which is just, all of that's just going to equal to 6. So the denominator now is just going to be equal to 6. Then we looked at the coefficients of both of my multiplication. 3 times 1 is 3. Rad 4 times rad 6 is rad 24. I could simplify rad 24 as follows. We can make a factor tree. We know that 24 is equal to 2 times 2 times 2 times 3. So we wrote this out. Square root of 4 is 2. Brought that out here. Left the rad 6 on the inside. Okay. And we got 6 in the denominator. 3 times 2 is 6. 6 rad 6 over 6. I could simplify my coefficients here. What goes in both 6 and 6? 6 does. Cancels each of them out, leaving just 1. 1 times rad 6 is rad 6. Anything over 1 is itself. Okay, does that make sense? Okay. Watch me do number 2. Number 2 is a little bit different. Okay, number 2. Number 2, we have a complicated denominator that has a radical in it. So, and it's a binomial. So check out the trick with what we learned yesterday. The trick from yesterday's difference of squares problem. So this whole denominator is a binomial. So the way I get rid of it is multiplied by the conjugate. This is how you make a conjugate. Watch. Open parentheses. Take the first number 4. Bring it across here. And then take the second term and make it the opposite, which is instead of minus rad 2, make it plus rad 2. Okay? Y'all see that? We do the same thing in the numerator. 4 plus rad 2. Okay? So the denominator now, we know it's a difference of squares problem, so these are both the same. So 4 squared is 16. Okay? Rad 2 squared is just 2, and put a minus sign in the middle. That's all you do in the denominator. You see that? Again, what did I do? 4 squared is 16. Rad 2 times rad 2 is 2. Put a minus sign in the middle. Okay? Numerator. Now we have to work this out. The whole numerator, like a binomial. So we got negative 2 times times 4 is negative 8. Negative 2 times rad 2 is negative 2 rad 2. Okay? Then we work out the next binomial. Oop. Okay, we got negative 2 rad 5 times 4 is negative 8 rad 5. Okay, and then we got negative 2 times negative 2 rad 5 times rad 2 is negative 2 rad 10. Okay, now we combine like terms. I'm looking at all my square roots now. Can I simplify rad 2 anymore? No. Can I simplify rad 5 anymore? No. Can I simplify rad 10? No, because 10 is 2 times 5. I can't take anything else. So all of these are going to be separate terms. Negative 8 we're going to leave there. It's a constant. 16 minus 2 in the denominator is 14. So in the numerator, I'm left with constant of negative 8. Minus 2 rad 2. Minus 8 rad 5. Minus 2 rad 10. Then I'm looking at all my coefficients of 8, 2, 8, and 2, and 14. They're all even, so what number goes into all of them? 2. So we could cancel each of these out. Actually, I won't, for the sake of seeing it. it'll be negative 4 minus rad 2 minus rad 5 minus rad 10 all over 7. That's your answer. And you might say, well, how is that any better than the first problem? It's better because look at the denominator. What's the denominator? 7. Did I make a mistake?
You missed an 8.
Oh, yeah, that's supposed to be a 4, right? Thank you. Let me fix that. Minus 4, rad 5, minus rad 10, all over 7. Okay? I know it seems like a complex answer, but again, the denominator now is a whole number, which means this is rational. This is a true rational term. Okay? So the hardest problem you'll deal with tonight, or on the test, is this number 2. Okay? So today's Wednesday. Let's have 1s tell the 2s. Okay, so number 3, we got rad 5 over 2 rad 2. So do we like that rad 2 in the denominator? No, we don't. Okay, so the way you get rid of the rad 2 in the denominator, I'll start you off on number 1. You could multiply it times 2 rad 2, or you could just multiply it times rad 2 in both the denominator and the numerator. Okay, I'll start you off. That's your hint for the first problem. Finish it up. You're really close. Rad 5 times rad 2 is rad 10. And then in the denominator, we have that 2. So we have a 2 here, and then we have a coefficient here of 1, right? So 2 times 1 is 2. Rad 2 times rad 2 is rad 4. What's the square root of 4? Just 2. So let's just go do one step there. The numerator. In my head, there isn't really a way I could simplify it. 10 is just 2 times 5. Those are both primes, so there is no way I could simplify rad 10. So we're going to leave that alone. And then the denominator, 2 times 2 is 4. Can't do anything else. The coefficient in front of 10 is a 1. So I can't really simplify 1 and 4. So the answer is just rad 10 over 4. Okay? Most of you are right there. And then there were a lot of you that got it right. Okay? Good. Number 4. By yourself. Ready, set, go. And remember, as you do number 4, the numerator, you need to act like the whole numerator is its own set of parentheses, okay? On all problems. Like rad 10 there, so we're going to multiply by rad 10 again. Okay, this is just like a binomial times a monomial, so you just distribute this rad 10. So what's rad 10 times 3? It's equal to 3 rad 10. Then I ask myself, what's rad 10 times negative rad 2? Negative rad 20. You following me so far? Okay, the denominator now is rad 10 times rad 10, which is rad 100. What's the square root of 100? 10. Okay. Now, we're going to simplify this some more. I know that rad 10 I can't simplify because 10 is 2 times 5, but rad 20 is like 4 times 5, right? You agree? What's the square root of 4? 2. So we're going to rewrite this as negative 2 rad 5, top left 3 rad 10, denominator is 10. Last step, I need to make sure all my coefficients are simplified. Is there any number that goes into 3, 2, and 10? Yes or no? No. Okay, so that's it. So only a few of you got it right. Raise your hand if you got that right first time. Okay. Raise your hand if you were really close. You just made a little mistake, but you know how to fix it now. Okay, good. Raise your hand if you were like way off. Okay, a lot of you were way off. So let's have you write this one down in your notes because this is a good one to have in your notes before we go on to the next one. I'll give you a minute to do that. So number 5. Bless you. Okay. I'll help you figure out the conjugate on this one. So we have rad 6 plus rad 2. So the conjugate here, all you got to do is take the denominator, put parentheses around it, of course. Always put parentheses around the whole numerator or denominator when you're working on large fractions. Okay, open parentheses. Take the first term, rad 6, bring it across. Just copy it. Take the second term, rad 2, copy it down. And then what's the opposite sign of plus? Minus. Okay? Bring the minus sign across. Minus rad 2. Okay, and this is just like yesterday. Rad 6 times rad 6 is? What's, what? Nope. What's rad 6 times rad 6? 6. What's rad 2 times rad 2? 2. Put a minus sign in the middle. That's your new denominator, by the way. You see that? You see how that just disappeared? Okay, keep going. Finish. You got 4 times rad 6. What's 4 times rad 6? 4 rad 6. What's 4 times negative rad 2? Negative 4 rad 2. Okay. What's 6 minus 2? 4. So I'm going to just rewrite this. 4 rad 6 minus 4 rad 2 all over 4. Okay, now this last step. Look at all your coefficients. What goes in all the 4s? 2 does, but think bigger. What's the greatest common factor that goes in all the 4s? 4 itself, right? So 4 cancels out with 4, and so does this 4. So all of these cancel out, leaving just 1 in each area. Can I simplify rad 6? Can I simplify rad 2? Nope, neither of those. So all we're left with is rad 6 minus rad 2. I saw a few of you getting this, so that's good. Does that make sense? Did you get that aha feeling? Like, that's good. I like that. That's good. Okay. If you're getting that, you're doing a good job. It doesn't mean you're not doing a good job if you don't get it. Just we need to seek that. Okay. Next one, last one, number 6. Yeah. Go. So on this particular problem, this is what you got to do. Look at the denominator. We have a rad 6. We don't like the rad 6 that's there. So we always pretend the whole numerator and whole denominator are their own, parentheses. They're not there, but they're not explicitly there, but we assume that they're there. So the denominator, we need to find the conjugate, which is just we copy the first term, which is 3. Copy the second term, 4 rad 6, and then bring it across the opposite operation, which is, in this case, we're going to put a plus there. Make sense? And then we're just going to copy that to the top right here. So we got 3 plus 4 rad 6. It makes the denominator super easy to find because now we got 3 times 3, which is 9. 4 rad 6 times 4 rad 6. 4 times 4 is 16. Rad 6 times rad 6 is 6. Okay, and then we're going to put down a minus sign there. That's the denominator, numerator. Okay. FOIL. Rad 3 times 3 is 3 rad 3. Then we got rad 3 times 4 rad 6 is 4 rad 18. Then we do it again over here. Negative rad 5 times 3 is negative 3 rad 5. Then we got negative rad 5 times 4 rad 6 is negative 4 rad 30. Okay, then we start working this out. Numerator, we got 3 rad 3. Can I simplify that anymore? Nope, we're going to leave that alone. Second term, 4 rad 18. Rad 18 is just like saying 9 times 2, right? Square root of 9 is 3. So it's 3 rad 2, but 3 times 4 is 12, so we're going to go 12 rad 2. Okay, continuing on, negative 3 rad 5. Can I simplify that? Nope. Next one is negative 4 rad 30. Rad 30 is 5 times 6. 5 is prime. 6 is 2 times 3. 2 and 3 are prime. We can't do anything with that, so we're going to just leave that alone. We got negative 4 rad 30. Okay. 9 minus 16 times 6. We do PEMDAS here. 16 times 6. 96. 9 minus 96. Okay. That's 9 minus 96. That's it. I can't figure this out. 16, 7. 87. And it's negative 87. Okay. Then I ask myself what number goes into all of these together. We have a 3 and the 4 here. Nothing goes into both 3 and 4, so we know this is your final answer right here. Okay. Wow, right? Kind of hard, right? This is required that you know how to rationalize the denominator, okay? It's one of those things, you clean up your problems by doing that. Okay, so that ends the lesson. So what I'd like you to do, you and your neighbor discuss these questions.